There were a number of really fascinating views available from Skylab in the area of the solar study, some of them seen for the very first time by human eye. In this case, there was an eruptive prominence on the disk of the sun, which cast out through the solar atmosphere, called the corona, to very, very high altitudes, an expanding gas bubble. This was moving out through the corona at a velocity of about 300 miles per second. And we brought back a number of very fascinating views of these sorts of events.
Well, on our flight, we were fortunate enough to be able to, first of all, record a solar flare from the very beginning all the way through the rise to the end. Based upon the previous experience of other crews, we were able to figure out what happens before a flare, then beyond target, and getting data as the flare came up.
We also know that when these large flares erupt on the sun, they throw out charged particles which reach the Earth in some 24 to 48 hours. These produce aurora, which we see here on Earth.
Well, the observation of Comet Kohoutek offered an unprecedented opportunity. It was very bright, and most notable was a sunward spike, which was in the opposite direction of the tail, very sharp and pointed towards the sun. Comets are important to science because we are able to observe what we think is primordial matter. That is, matter which has been around since the birth of the solar system, if the comet came from the solar system, or if it came from outside the solar system, then it's an opportunity to observe something which was not created with our solar system, but in the regular stellar scheme of things.
We also had several smaller experiments intended to look at the ultraviolet radiation coming from stars throughout the galaxy in which we're in, as well as radiation coming even from other galaxies. And these experiments were extended out the scientific airlock of the Skylab and looked at the ultraviolet radiation coming from the sun, allowed it to be dispersed so the image actually looks like it has a long tail on it, and then he can see just what radiation is coming from each of these stars.
Throughout the 3 manned missions, flight crews evaluated the day-to-day activities of living to see what might be improved in future spacecraft design.
Mobility was, I like to refer to it as the Peter Pan mode. You could really just push off and move around. Within the workshop, the thing that surprised me most was how quickly we all adapted to being fairly precise.
It's very much like the sensation you get when you're skin diving or just floating around in the water.
Well, as far as working in zero gravity and moving yourself, it was a delight in comparison to 1G on the surface of the Earth.
Once your eyes see something, then you relate to it, and you say, whatever is above my head is up, whatever is below my feet is down. Doesn't matter whether it's the floor or the ceiling.
Every evening, after dinner and all the work was done, we always had to take a trip or two around the water ring lockers or just go up there and free fly.
We also found that we could have quite a bit of fun doing tricks and stunts and flips and rolls that weren't possible here on Earth. Food aboard Skylab was a very good treat when compared to earlier space missions. Probably the best feature was the fact that we had the ability through a warming tray to put all of our food out and heat it so that when you sat down to eat, you could eat a variety of foods all at once. Probably the favorite of everybody's up there was ice cream and strawberries.
Of course, it was necessary to clean house up there once in a while, too. All of our air was filtered through a big screen within the orbital workshop. And as the air went through this screen, little particles would collect on the screen, small items that needed to be vacuumed up. And so every day or two, we would vacuum off the screens.
We found housekeeping to be not as difficult as here on Earth. One reason was that we had a planned place for every item.
Personal hygiene-wise, it was necessary for us to perform up there about the same way it is here. We brushed our teeth, we combed our hair, we shaved, we washed, We did have a shower. We found, however, that we could almost keep clean enough by using sponge baths, by washing ourselves off with a wash rag. Although we did use the shower on several occasions, and I think for future space stations, the shower would be a good idea.
We slept in a sleeping bag-like device, which had straps across it, so once you were in the sleeping bag and all snugged up, so to speak, well, you felt very close to what you feel like in bed on Earth.
We had on board, of course, EREP, which is an abbreviation for Earth Resources Experiments Package. The primary purpose of this package was to evaluate the techniques and equipment to be used in studying the Earth's surface.
The Earth Resources multispectral camera consists of a battery of 6 cameras all pointed at the same place on the ground. Now, through using suitable filters on the front of these cameras and putting different kinds of film in there, some susceptible to visible light, some that'll measure infrared light, some that'll measure other frequencies of light, you're able to record what is being radiated from the ground in these different frequency ranges.
There's been a lot of significant data gathered in the area of determination of faults. The Southern California area, of course, has been troubled with earthquakes for many, many years, and we're just beginning to really understand the fault structure in that area. We also have got some excellent photography of the fault structure as it extends on down into Baja California. Then over in New Zealand, we got some of the Alpine fault. And we think that possibly better knowledge of the fault systems around the Earth will give us a better understanding of earthquakes, and we can learn to better predict earthquakes.
You can imagine that if we had the ability to forecast weather, literally millions and millions of dollars in crop savings alone would result. And it's just the first step, of course, of weather control.
We've been able to give them three-dimensional looks at cloud formations in the areas of cyclones, typhoons, hurricanes, and the like. We've given them some photographic data that we think is going to answer a few questions that have never been answered to date anyway on just exactly how the Earth and its atmosphere interchanges energy back and forth.
Food supply is a very important factor for all of us here at home, not only in this country but for the entire world, of course. First of all, we can survey the amount of land that is devoted to the production of these crops. We can even estimate what the yield is going to be, depending upon what its temperature and rainfall and so on is. Also, we can see where there may be areas of infestation. These instruments photograph the Earth in a variety of different spectral ranges, clear down into the infrared. In other words, some disease like a corn blight may have been started. We can see areas where the forests have had significant infestations. So this all goes together to help us put together a better pattern of the total world production of food and other things of interest to people in this country and overseas as well.
We took a good look at the Falkland Current. We could see some of the staining, this plankton blooming, the little organisms that grow essentially in the deep water, and then when the water wells up from below, it brings up this green plankton, and from space it looks like a green stain.
The plankton is sort of the bread of the sea, and it starts the life cycle in the sea. And if you can track the plankton, you can track the smaller fishes, which are going to track the larger fishes, the food fishes, which are good for commercial people.
We took some excellent pictures of the drought area of Central Africa, trying to discover the total pattern of the drought, to see if it could be stopped in some way by suitable planting or suitable cultivation or preventing cultivation of certain areas. So although we don't know the full techniques that would be used in this case, at least we can get a sort of a handle on food production and enhance it in some way.
As far as man-made pollution, I think that probably the most outstanding visual evidence of this is in the Great Lakes. And it starts at the source of the Great Lakes, the western end of Lake Superior, where you can see pollutants along the southern shore of Lake Erie. You can see where every large creek or small river empties into the lake.
We noticed in areas like Mobile Bay and the mouth of the Mississippi River and several other river areas around that you could see the silt moving out into the various harbors and bays around the world. Part of this, I think, we can probably blame on man because of poor soil conservation practices upstream.
Much easier to take a picture or to look down from orbit and try to survey the situation and find the areas most likely to be sites for future oil fields, for example. We think that this technique is going to make quite a lot of energy sources available that just haven't been discovered yet because of the vast surface of the Earth.
Earth, the Sun, the stars, prime targets for Skylab investigations. But within the workshop, too, experiments and demonstrations covered a broad range of science and technology. In early February 1974, the third crew retrieved for the last time the film, magnetic tape, the samples and specimens for return to Earth. The operational phase of Skylab was nearing a successful end. The ongoing science phase, fueled by the aggregate of data from all three missions, would last for the next several years.
Say goodbye for her. She's been a good bird. Roger, sure has. Okay, gas ascension at 1608. Roger, Grim.
I don't think there's any real limit to how long man can stay in space, as long as he never loses sight of the fact that sometime he's going to have to go back to 1G. And if he keeps that in mind and keeps his cardiovascular system and his muscles and his bones toned for that eventuality, then there's no reason to believe that man need worry about how long he spends in space. I don't think there's a limit to that.
We all know that the Earth's resources are limited. And in order to enjoy the benefits of the resources of the Earth that we have enjoyed in the past, we're going to have to learn how to manage what we have more efficiently. We're going to have to learn how to find new resources to improve our quality of life here on Earth.
The solar physics community has about 5 years of very intensive work ahead of them. We have brought back so many thousands of pictures, and this is actually on the order of 100,000 photographs now of the sun, which they have to look through and analyze in order to better understand all of this activity that's going on the sun.
Also, we have operated very extensive and complex equipment in Skylab and established that this is a viable operation, that you can do it. We have learned from Skylab exactly what features are best, what features to avoid in the way of designing, say, a spacecraft or space station itself, or even certain pieces of scientific equipment.
I don't think anybody really knows what man's future is at the moment. However, we do know that what man's been capable of doing, and not only has he always done, he's always done it to his advantage. So I think maybe space exploration is just the beginning of man being able to go out to other areas of the universe. And once he's able to go out there, he's going to find uses for it. He's going to go out there and live, and he's going to populate it, and he's going to make a better life for himself and for the rest of the people of the Earth in doing so.